So today we're going to be, our objective is, to understand how to factor any trinomial. And to do that, we're going to play a game. We're going to play what's called the product sum game. And this game, really what it helps us do is to look at factors very quickly in our minds and find matches, okay? Tomorrow I'm going to talk about just listing factors and looking for matches visually that way, but this game that we're going to play, the product sum game, is going to help us figure out what factors go in. It's going to also force us to review factoring by grouping. Now, as we play the game, depending upon what the original trinomial looks like, you may notice a pattern that will shorten the length of time that you need to work out the answers. And I'm not going to talk to you about that. You guys, if you see it, we can talk about it tomorrow, but I'm not going to put it into the notes. Because every time I talk about, ooh, did you guys notice this? Then you want to use it every single time. Patterns only work in certain situations, so you have to be aware of what situation does it work. Okay, so basically let's go through some vocabulary. So I've got three terms in my trinomial. So we notice that three terms make a trinomial. We've talked about the vocab trinomial. But what I want to do is to name each of the parts, because I'm going to use that vocabulary as we go through and play the game. Okay, so the guy that comes in front with the x squared. Now, we can play the game even if it's not an x squared. We can play this game anytime we have a pattern of the first exponent is even and the second exponent is half of the first one. If we have that idea, then we can play this game. So it could be x to the 6th, x cubed. It could be x to the 8th, x to the 4th. So if that's how our exponents match up in our first and second terms, we can still play this game. This guy is called the quadratic term. When he's to the second power, he's specifically called the quadratic term. But in general, in our word problems, we're going to call him quadratic term. Okay? The next guy is called the linear term. And if you remember back to chapter 7, when we were graphing, we had y equals 3x plus 2. So when we didn't have an exponent on our x, we got a line. So that's why he's called the linear term. And then what do we call a value that stands alone? He's a constant. Now, this strategy I'm going to share with you, this game we're going to play, the constant is allowed to have another variable. So you may have x squared in front, you may have y squared in back, but then you're going to have a combination of the variables in the middle. Okay? So we need to understand quadratic term, linear term, constant. Okay? Because I'm going to use those. So what we're going to do is go through the game, and then we'll go back and write down a couple of notes to go along with the game to refresh our memories. How did it happen? All right, so let's take this guy, x squared plus 3x plus 2, and this is how the game works. Now, I use a visual to help me, and some people call this the X factor, some people call it the X box. I personally call it the lattice because I'm into gardening. And if you put a whole bunch of these X's together, it looks like fencing called lattice. And you can grow climbing like beans and sweet peas like to grow in a lattice. Okay, so that's just, you'll hear me kind of go interchangeably with those three things. In other words, you just need an X. Okay, what we're going to do is we're going to take the coefficient of the quadratic term and the constant, and we're going to multiply them together. That is going to be called the product. So he is called the product. Remember, the game is called the product sum game. So the quadratic coefficient times the third term's coefficient That's their product number. So that's the product in this. Then I want you to take the coefficient of the linear term. And you can do signs, is the better way to do it. Let's do that. Include the sign. And he's going to go down here. He's called the sum. Okay. Now the game begins. Can you think of two numbers that when you multiply them you get 2, but when you add them you get 3? How do I get all the add? It's by the signs. Two numbers that multiply to give me, and I can add another sign here, positive 2, that are going to add to give me positive 3. And those two numbers would be what? Say again? Okay. Positive 1 and positive 2. These are called factors. So what your brain is doing is looking at the factors of the quadratic term, factors of 1, looking at the factors of the constant, 1 and 2, trying to pair up those factors to multiply by each other, outer, inner, like in FOIL, to come up with the answer. So how does this relate to what we did yesterday? Well, what I'm going to do is I'm going to take that middle term, 3x, and instead of writing it 3x, I'm going to split it into two middle terms. And I'm going to split it into plus x plus 2x. And where I got those from was from the factors that I figured out from playing my game. Okay? And then I just factor by grouping. These two have an x in common, giving me x times the quantity x plus 1. These have a positive 2 in common, which gives me an x plus 1. And then overall, they have an x plus 1 in common, and the two coefficients make an x plus 2. And there's my answer. Patrick.
The x, can we put like the 1, or sorry, do we have to put like the lesser term on like the left?
The order that you put those two middle terms does not matter. I am going to caution you when we get into different signs, and we'll do some examples like that. I put the negative in the first place and the positive in the second place. That way I'm not factoring out a negative, because that seems to be the biggest error kids are making, is pulling out a negative. Okay? Molly. Somebody's phone's going off.
How do you, so the x in like x2 and then parentheses x plus 1, how does the outside x get, like, where does it go?
What outside x?
So when you divide it, you go x and then parentheses x plus 1. And then in the answer, it's just parentheses x plus 1. Where does the x go?
The one in front, he's right here.
Oh, okay.
Okay. So the coefficient of both of those groups become their own binomial.
Oh.
Okay, and that's what you missed, Molly, yesterday when you were sick. So do make sure to go back and look at the video, okay? All right, so, Jason.
Does this strategy just break up the middle term so that I can go into like 4?
It does break up the middle term, but it's explicitly has to be these values, because it's the only way it'll give us what we need. So we don't touch the quadratic term, we don't touch the constant term, we just it's called splitting the middle term. And that's what the high school calls it, and that's what I've seen on testing, is called splitting the middle term. Okay, so let's go back and we're going to jot down a couple of ideas that we needed to do. So, we can do colors. First, we needed to multiply the coefficient of the quadratic term and what we're calling the constant. This becomes your product number. Okay, and remember in the x it goes on the top. And then we're going to take the linear coefficient and his role is to be the sum number. Sum as in S-U-M, not S-O-M-E. The game entails come up with two factors that multiply to equal the product but add to give the sum. That's your game. Some factors have very few, or some terms have very few factors. Some of them have a ton, so it takes a little longer to process through it. You will come across some very large numbers on your homework in which you have to really think about factors and pairings, and it takes you a little while to come up with the match, okay? Most of them are going to be fairly simple. So a couple things to go back and add is to make sure we include signs on the product number and signs on the sum number, because those signs are going to dictate. Now, I tend not to put my variables as part of these. Other people do put their variables as part of them. I find it easier just to kind of lay out and realize, in order for my middle term to have x as part of the linear term, then x is going to be what's going to be in front of my binomials. Okay, so that's kind of how I've just learned how to do it. So we'll go over that again. All right, then what you're going to do is to split the linear term into two linear terms using the factors found in the game. And the last thing we do is factor by grouping. Okay. Now, what I haven't mentioned that is always something that we look for in the beginning is look for a GCMF. So I'm going to go back and add him in there. Look for GCMF. Sometimes they do lurk, and if we aren't careful, we'll have some issues. So you do have a secondary way to catch if you forget to look for a GCMF of the whole trinomial, is to, when you do the factoring by grouping and you look at your factors and you realize, oh, there's something inside of this I can still pull out, you can factor it then, okay? So bottom line is your product goes here, your sum goes here, and your factors that we're going to use go here. Okay. So it's just nice to kind of have things laid out for you. Okay. So let's do a couple. Another one. Let's do one more that has a linear or a quadratic coefficient of 1, and then we'll do some with quadratic coefficients that aren't 1. And we're also going to do one that's a difference of squares, so you can see how to play this game. All right. So directions are going to say factor. And let's do one, I'm trying to find a good one. Oh, let's throw one in there with two different variables. That'll be good. Let's do, I want to find one with different signs. Oh, this is a good one. X squared minus 8x, no, let's do it this way. X squared minus 8xy minus 20y squared. According to this problem, what's the product number? Not 1. Okay, what do I multiply for the product number? Quadratic coefficient. Constant. So what's 1 times negative 20?
Negative
There's my product number. Okay. What's my sum number? Negative 8. So here comes the game. What are two numbers that when I multiply them, I get negative 20? So we have to think about signs now. But when I add them, I get negative 8. So, couple clues. My product is negative. What types of numbers can I multiply and get a negative? Say again?
positive and negative.
We have to have a sign of each. Okay? So what I can do is put those signs in. Now, how I put my signs in is I match whatever the denominator, the sum number is. I need to have my bigger number attached to the negative. Okay? So now, two numbers that multiply to give me negative 20, but add to give me negative 10. Maddie. Negative 8, sorry.
Me,
Yeah, Maddie.
negative 10 and 2.
So we get a negative 10 and a positive 2. Okay, and I kind of gave away that answer, didn't I? Do that all the time. So now what I have is I take x squared, and I have the minus 20y squared. But in the middle, instead of it being negative 8 squared, I'm going to put negative 10xy, and I'm going to put positive 2xy. And so one of the things I was talking about is if you have two different signs, put your negative one in the right after the quadratic term, and put the positive one in the third spot. If you have no other option and they're both negative, then you have to deal with pulling out a negative. But this will avoid some of those kind of errors. So then we just factor by grouping. These two have an x in common, giving me x times the quantity x minus 10y. These have a positive 2y in common. So when I factor out the 2y, I get x minus 10y. So I ended up having a match, and my answer is going to be x minus 10y times, take those coefficients, x plus 2y. And there's my answer. Okay? Serena. It doesn't, but again, the strategy I'm trying to share with you is if you put the negative one first when you split the middle term, then you won't be pulling out a negative. Sometimes they'll have two negatives and you can't help it, and you're just going to have to deal with it, okay? All right, so let's do one like this. We'll do, actually I want to find a better one. Let's do this one. Let's say we've got 49 minus 42b plus 9b squared. Now, a lot of you are going to say, ooh, I don't like that the variable's in the back. Can I rearrange it? And the answer is, yeah, you could, but the reality is you don't need to. You can leave it exactly in the order that it is. So here's where the game gets a little bit more complicated, is that we're going to look for coming up with a product. Now I've got to multiply a 49 times a 9. Okay, that's going to be kind of crazy. So in my lattice, I'm going to get, let's see, 9 times 9 is 81. And I carry the 8, and 36 plus 8 is going to give me 44, right? Is that right? Okay. Is that right? You guys aren't acting real positive. Yeah. Okay. Some number is this guy here. All right. When I'm faced with a very large number, this is when I start playing around with factors. And I go, well, I know 49 times 9. Oh, and I need to put, this would be a positive. 49 times 9 is going to give me the 441. But if I take 49 plus 9, because I have to add those, right? Because the product is a positive, so the only way to get a negative when the product is the same is I'm adding two negatives. That would add to give me 58. So that means I'm going to have to think of a different way of breaking this down. So then I think about 49 is 7 times 7. And if I do 9 times 7, I get 63 plus 7, gives me 70. That doesn't match what I need. So now then I break down the 9, and then I have 21 plus 21. Finally, I find a match. So I have to play with factors to come up with my match. So in order to match this sign, they both have to be negative, because two negatives together make a positive, and two negatives add up to give us a negative. And the two factors that ended up working were negative 21 and negative 21. So when I rewrite this problem, I have 49, and then I have minus 21b minus 21b plus 9b squared. And then I factor by grouping. These two, let's see, they have a 7 in common. That gives me 7 times the quantity 7 minus 3b. And then here comes the unfortunate, because I did have a negative, I just have to deal with it. I'm going to have to pull out the negative, and these two have a 3 and a b in common. So a negative divided by a negative is a positive, 21 divided by 3 is 7, b divided by b is 1, and then plus, or no, this is going to be a minus. 9 divided by negative 3 is a negative 3, and then b squared divided by b is b. I ended up getting a match. So I pull out the 7 minus 3b, and then these two form their own binomial. And you should notice something interesting about our factors. What do you notice? They're the same. So that means I write it once with an exponent of 2. Now, getting that answer, what does that tell you about your original trinomial? It's not the difference of squares. It was a trinomial square. I could have used that other pattern, and it would have been much faster for me to get to the answer, because I would have tested 49 a perfect square? Yes. 9b squared a perfect square? Yes. Is 9b squared positive? Yes. And then take those two square roots, multiply them by negative 1, because that's the sign from the middle, and then double the answer, and I would have had negative 42b. I already have the answer sitting right there. That's the kind of stuff that we have to watch out for. Okay? Difference of squares real quickly. 25x squared minus 4y squared. Okay? When I play the game, the product number is for the first and last term. That's going to give me 100. Negative 100. What's the sum number? What's the linear term's coefficient? Where is the linear term? There is none. How do I know what's a linear term? It's the only term that isn't having exponents on it, right? So we say we get a 0 here. All right? So what are two numbers that multiply to give me negative 100? It has to be a positive 10 and a negative 10. So this would give you 25x squared minus 10x plus 10x, or it'd be xy to be honest with you. Should be xy. And then we have minus 4y squared. And then we just factor by grouping. The first two are going to have a 5x in common. The second two are going to have a, what is it, a 2y in common, and then we factor it out. So we get 5x times the quantity 5x minus 2y, and then we're going to get plus 2y times the quantity 5x minus 2y. So we get 5x minus 2y times 5x plus 2y. The pattern is actually faster to solve this problem than to do it this way. Okay? All right. Good luck with your homework.